So here we go. Oh, my screen is frozen. Hang on. Excuse me.
I can do my homework.
There we go. All right, so number one, I've said this 1,000 times. I'll keep saying it. In math, we don't read from left to right. We read according to order of operations. And there's a lot of order of operations stuff to be had here. Number one, did you guys notice all the parentheses over there? And did you notice how there's like parentheses within other parentheses? So whenever you have that situation, you start with the parentheses that are most on the inside. And so if I were to try to write this one out and do a couple of steps, I just start off by writing 7 minus negative 3 quantity squared. I've got the negative of 2 cubed minus. And then finally I get to those inner parentheses. And maybe I'll do, if it's okay with you, you're probably getting good enough to do this. In those inner parentheses, 5 times 3 minus 5. Can you just do that in one shot?
Oh, yeah.
What do you get when you do 5 times 3 minus 5?
10.
It's 15 minus 5, right? 10? Okay. So I'll put a 10 right there. And then I'll keep going because there's a lot more work to be done in the parentheses. So maybe for my next step, I would write 7 minus negative 3 squared. And then the negative of 2 cubed. You know what? I'll just go ahead and do that right now. What is the negative of 2 cubed? It's negative 8, right? So negative 8 minus 10 quantity squared. Ooh, these numbers do get kind of large, don't they? That's okay.
It gets really big.
That's okay.
Well, actually, really small.
There's one more. Yeah, that's probably accurate, Callie. Negative 8 minus 10 is negative 18. And then negative 18 squared should be positive, right? Positive 324?
Yes.
Okay. So 7 minus negative 3 squared. We got 324 right there. Interesting. Okay. And 7 minus negative 3 in the parentheses squared is 9. And let's see here, 9 times 324, 2,700, 2880, 2916. Is that right? So 7 minus 2916, negative 2909.
Yes, I thought it.
Interesting. Hey, so something to think about here. I normally for you guys to do this without, breaking out the calculator. I can tell you that I probably made a little mistake on setting this one up. I should have made this a plus sign right here. Oops. If I would have made that a plus sign, I think the numbers would have been far more manageable. That makes sense? So anyways, I'm not really expecting you. So I'm not really testing out your powers of multiplying or dividing large numbers. More interested in your order of ops. So if you made it all the way through that and you got it right and you handle the large numbers, that's awesome. If you struggled to do 9 times 324 without a calculator, I'm okay. I'm not going to really ask you to do that. So chalk up the largeness, or as Callie more accurately said, the smallness of that number. Chalk that up to I probably should have made that a plus in there. Otherwise, if you follow the order of ops, I think we're in good shape. You okay? Are there any questions? Any questions at all? Okay. Hopefully the other ones were not quite so complex. For number 2, what would you do first?
Distribute.
You could distribute.
No.
Or couldn't you do the work in the parentheses first?
Yeah. Oh. I added and did the work.
I did the work in the parentheses.
You know what? You could do it either way. Let's do it both ways. Since Ben suggested distributing first, let's do that. If I did distribute it, I would get 2 times 1 is 2, 5 times 4 is 20, plus 2 times 7 is 14, and 5 times 12 is 60. Then did you just get a common denominator from there? Ben, is that what you did, or did you reduce and then do that? All right, so if you do a common denominator, you've got to multiply by 3, top and bottom over there. That would give me 6 60ths plus 14 60ths, which is 20 60ths, which, Ben, reduces to?
1.
Ben, your voice is sounding somewhat feminine this morning.
Yeah, I know. Someone's stealing my breath.
Interesting. And it came from over there, which is a really amazing trick. I don't know how you do that. anyways, the other way would be to do the work in the parentheses first, right? So if I'm going to do the work in the parentheses first, I would need a common denominator. Wouldn't that be 3/12 plus 7/12 inside?
10, 12.
So then when I add those up, I get 2/5 times 10/12. Then maybe you multiply, or did anybody do some cross-canceling? Because there's quite a bit, right? The 2 and the 12 would cancel to be a 1 and a 6. The 10 and the 5 would cancel to be a 2 and a 1. 1 times 2 is 2. 1 times 6 is 6. And look at that. Bless you. It's the same answer. So whether you distributed, like Ben suggested, or followed order of operations correctly, like others suggested, you get the same answer as long as you do it correctly, as long as you don't make stuff up or make a silly mistake. So take a look at numbers 1 and 2. Any questions at all from numbers 1 or 2? All right. So then number 3. Number 3 is a little more of a newer skill that we've been looking at. So do you guys see a distributive property in there anywhere?
Yeah.
What's being distributed?
3.
A negative. I would say a -3. I would say that the sign in front of the number needs to go with the number. So my first step would be something along the lines of 5x minus 3x plus 3. Did you guys get that plus 3?
I sure
That's the tricky one.
Oh, wait, no, I didn't.
Oh, man. The good news is this is just practice. So if you make a little mistake, you can always fix it, right? You guys get that?
Yeah. Wait.
That's the point of this. This is just practice. So if you mess up or you thought you messed up, you can always just fix it, right? Just fix it. Okay, and then we've got some like terms. I've got a 5x. What's like the 5x?
9x.
The negative 3x.
And the negative 3x. Those are all like terms. When you add those up, you get 11x. And then a positive 3 added to a positive 4. I think we should be getting 7.
How did I get 7x for 5x minus 3x? Because you did.
Maybe you said it was negative 2x plus 9x would be 7x?
No, I don't know.
Possibly?
It's all good.
Okay. As I walked around and peeked over shoulders, I saw a ton of people that had 11x plus 1.
Yeah,
I know.
because I forgot.
You know what that tells me is that maybe we made a mistake with the plus 3, right? We didn't distribute the minus sign with the 3. So you want to watch out for that for sure. And then lastly is one of our newest concepts, and that's number 4. Translate 5 less than the product of x and 3. So 5 less than the product of x and 3 would look like this: 3x minus 5. That is 5 less than that product, right? Remember, less than means subtraction. Something's being subtracted, and 5 less than means we subtract 5. Product means multiplication, so product of x and 3 would be x times 3 or 3x, same thing. And then the words is, at least. So the word is really key, isn't it? So is at least means, it's an inequality, right? Means greater than or equal to. So greater than or equal to 17. Remember, if I'm telling you the least it could be, couldn't it be bigger than that?
Yeah.
If I'm telling you the most it could be, couldn't it be less?
Yeah.
It could be smaller. Yep. Okay, so there's number 4. Any questions on number 4 or number 3 for that matter? Anything I can teach? Questions I can answer? I mean, whatever. Okay, fair enough. So did you guys notice that this was maybe just a degree or 2 tougher? Forgive me for the big numbers on number 1, but beyond that, wasn't this like a degree or 2 tougher than some of the other DMRs we've done? It's because it's getting to be more contemporary, stuff that you've just learned in the last 2 to 3 weeks, maybe, or just reviewed, maybe something that you're a little bit more rusty at from middle school. I don't know. So anyways, we'll practice again tomorrow, file those away, and